Okay, let's have a look at what happens when we have more than one moment. So we basically want to be able to add moments. So let's imagine the situation again where we've got a bar, we're going to fix it. So it's fixed at that point. And again, step one, always, where's the origin? Where are we going to measure from? So if we put, that's our origin, is that fixed point. And we're going to have two forces working on it this time. So we're going to have a force, we'll stick with our 200 newtons, pulling it down at 1.7 meters. And then we're going to have another force along here, which is going to be only 50 newtons. And that can be a further 3.3 meters along there. Okay, and the question we want to ask is, what is the total moment acting on the bar? What is the total effect of this thing in terms of turning? 250 newtons. So you just added these two together? Yep. Now let's have a look and see if that makes sense. So let's just look at the two things one at a time and figure out the moment for each one and then see what the total moment is. So like I said before, the first thing you have to do is define your measuring point, define your origin. And I've done that, I've bunged an O1 here. So any distances, we're going to measure from O. Okay, so let's look at, I'll label these forces. So let's call this one force A and this one force B. So we're going to work out the moment due to force A. So moment A is equal to force times distance. So what's the force we're working with here? It's not difficult, it's 200 newtons. And the distance is, and we did that before, so that's 340 Newton meters. Is that finished? What else do I need? No. Before I move on to the second one, have I finished that moment? Is that everything I need about that moment? No, not for, yeah. Good try, Nathan. For the moment, no. Clockwise, thank you. It's got to have a direction. Yeah, a moment is not complete until it has a direction. So chuck a direction on, so it's going clockwise. And now we'll have a look at moment B. And likewise, that's a force times the distance. So it's 50 newtons times what distance here? 5 meters. Why 5 meters, Nathan? You're correct. Why? Exactly. So all your distances must be measured from the origin. That's why we set the origin at the start. So if you're measuring this force, it's the full distance. It's not the 3.3, it's from the force to the origin. Every measurement has to go back to the origin. Okay, so that's 5 meters, which is 250 Newton meters, anti-clockwise. So my total moment is equal to, I heard the answer over here somewhere, 90 Newton meters clockwise. Okay, so it will turn clockwise. In this case, the bigger force will win, but not by a huge amount. I mean, that force is trying to turn it 340, and 250 of that is countered by the other force. So all we're left with is 90 Newton meters in the clockwise direction. Okay, so if you want to add moments, you have to calculate moments and then add those. You can't just add the forces at the start. And you've got to take each force has got to be associated with its distance. Work out its moment and then join those things together. Okay. Questions, comments, things you want to throw at me? It's all good? Okay, yeah, so that's a really important idea. Work out the moment here and the moment here and add the moments. Okay? And different directions, effectively a different sign. So this one's effectively negative. So if you're trying to run your calculator, it's 340 plus negative 250 because it's anti. So it's effectively negative if you want to add.
So is that first force always going to be clockwise?
It's clockwise because it's fixed here. So when it tries to turn the bar, it turns it that way. Which, see, it's conveniently the same. Yeah. Whereas this one is trying to push it that way. Yeah. So it's really important when you're trying to decide that you decide where your fixed point is. If you don't know where the fixed point is, anything can happen.